Okay, today we are on page 167, lesson 84. We're continuing to solve problems using data and our bar graphs. So before we start today, I'm sure you saw I had some writing up here. I wrote it so it's a little bit easier to see. Some things that we need to think about today. Fewer, that might not be a word that you're familiar with, means less. Okay, so when we talk about numbers, we talk about less, but when we talk about people or things, we talk about them being fewer. How many more and how many fewer usually means the number is going to be getting smaller. So if you see either of these, think about your number getting smaller and subtracting. Okay, let's take a look here. We have a computer center, that's our title. Down here we have activities. We have projects, homework, emails, and games. Over here are the number of students. So if we look here, our first thing that we want to do is write out all of our numbers. So for projects, we go up. We're going up by twos. 0, 2, 4, 6, 8, 10, 12. So 12 people like to do projects in the computer center. Okay, we look at homework. Okay, we go up 2, 4, 6, 8, 10, 12, 14 people like to do homework in the computer center. Okay, some people like to email. 2, 4, 6, 8. Oh, it didn't go all the way up to 10, but it wasn't at 8. So the number that would be in between would be 9. And games, 2, 4, didn't get up to 6. So what number is in between 4 and 6? If you said 5, you are correct. So 12 people like to do projects, 14 like to do homework, 9 like to do email, and 5 like to play games. Let's take a look at using this information. You can use a model or write a number sentence to help you answer the questions about data. The bar graph shows the different ways students use the computer center after school. How many more students use the computer center for projects than for games? One way, use a model. Find the bar for projects. The bar ends at 12, so 12 students use the computer center for projects. Find the bar for games. The bar ends halfway between 4 and 6, so 5 students use the computer center for games. Count back along the scale from 12 to 5 to find the difference. Again, that's another subtracting word. The difference is 7. So what they did here is 12 people like to use the computer center for projects, and 5 like to use it for games. So 12 minus 5 equals 7, which is what they had down here. Another way is to write a number sentence. Students subtract to compare the number of students. Think there are 12 students who work on projects. There are 5 students who play games. 12 minus 5 equals 7. So 7 more students use the computer center for projects than for games. Okay. Use the computer center bar graph for questions 1 through 3. So we're going to be referring to up here. Number 1, how many more students use the computer center for homework than for email? Now remember, in the beginning, we talked about how many more. That means that there are going to be fewer students, less. So, how many students use the computer center for homework? If we look up here, 14. And how many use it for email? We look up here, 9. So we want how many more students? So we have 14 minus 9, which would give us 5. So 5 more students. How many fewer students use the computer center for games than for homework? Again, how many fewer, meaning we're subtracting. So we have to look back at our graph. So how many students use the computer center for games than for homework? So here, homework is 14. Games is 5. So we come down here, we have 14 minus 5 gives us 9. So 9 fewer students use the computer lab for homework than for games. Do more students use the computer center for projects or for email and games combined? Combined. When we see that word, we think about bringing numbers together. So this is actually a two-step problem. First, we have to think about email and games and put them together. So 9 students like to use the computer center for email. 5 like to use it for games. We're combining those two numbers together. So 9 plus 5 equals 14. Now we have to look at, it says, how do more students use the computer center for projects? If we go to projects, 12 students like to use it for projects. So over here, this 14 is for email and games, and projects equals 12. So if we compare these numbers here, 14 is greater than 12. So more students use it for games and for email. Okay. So again, projects was 12, and when we combined email and games, that was 14. So more students use it for email and games. Okay, let's take a look at page 168. Solve problems using data. Let's take a look at our table over here. Our title is Favorite Hot Lunch. Down here are the lunch options: hot dog, chicken patty, pizza, grilled cheese. Okay, so for hot dog, the number of students over here, if we look at our numbers, again, we're counting up by 2. 0, 2, 4, 6, 8, 10, 12. So if we look at hot dogs and we look at our bar, 8 students like the hot dogs. Here we're talking about the chicken patty. 2, 4, doesn't quite go up to 6, but it's more than 4. 5 students. Okay, pizza. 2, 4, 6, 8, 10. Doesn't go up to 12, but it is more than 10, which gives us 11. Pizza looks like the big winner here, but let's check with grilled cheese. Only 2 students like to order the grilled cheese. Use the favorite hot lunch bar graph for 1 through 3. How many more students chose pizza than chose grilled cheese? So that's one of our phrases over here that we've been talking about today. So it says here, subtract the number of students who chose grilled cheese, which is 2, from the number of students who chose pizza, which is 11. 11 minus 2 equals 9. So 9 more students liked pizza than grilled cheese. Number 2, how many students did not choose chicken patty? Now this is a tricky one. So chicken patty, if we look here, 5 students chose chicken patty, but they want to know how many students did not choose chicken patty. So they're talking about students that chose hot dogs, students that chose pizza, and students that chose grilled cheese. So we need to add these 3 numbers together because those are the students that did not choose a chicken patty. So if we look here, we have 8 plus 11 plus 2. So I'm going to stack over here 11 plus 8. 1 plus 8 gives me 9. 1 plus nothing gives me 1. So I have 19. So that was for the hot dog and the pizza, but I still need to add in the grilled cheese. 19 plus 2, I have 9 plus 2 gives me 11. Put down the 1, carry the 1. 1 plus 1 is 2. So there were 21 students who did not choose chicken patty. How many fewer students chose grilled cheese than hot dogs? Blank, fewer students. So again, use this chart here. Notice these words, how many fewer. Think about our phrases over here and how you could solve for number 3. Use the ways to get to school bar graph for 4 through 7. Ways to get to school. That's our title. Transportation. Some kids take a car to school. Some kids take a bus. Some kids walk, and some take a bike. Over here's the number of students. Again, our chart keeps going up by 2s. So the first thing we're going to do is write in our totals. So 4 students take a car. We go up here. 12 students take a bus. Okay, walk, I see 2, 4, 6, but not up to 8 yet. 7 is in between those. And bike, it's in between 2 and 4, which means 3 students bike. So 4 students take the car, 12 students take a bus, 7 walk, and 3 bike. How many more students walk than ride in a car to get to school? So again, how many more is on our list of words to look for today? I'd like to see if you can solve number 4 by yourself. How many students walk and ride a bike combined? We talked about combined with question number 3 here. So think about the operation that we used here. I'll give you a hint. It's going to be different than the operation you used in question 4. Okay? Let's look at our problem solving. Is the number of students who get to school by car and bus greater or less than the number of students who get to school by walking and biking? So here they want you to think about the car and the bus together. And they want you to think about grouping together walking and biking. Okay, so here I want you to tell me how many students take the car and the bus. And here I want you to think about how many students walk and bike. I'm just going to change that to bus since there are 2 B's there. Okay, then I want you to tell me here, is the number greater going for car and bus or walking and biking? So solve that one for me. Number 7, what if 5 more students respond that they get to school by biking? Would more students walk or ride a bike to school? Well, here, if we look at how many students bike, here we have 3 students biking. But if 5 more decide that they're also going to take a bike, how many students would that be? Then, once you get that number, you're going to compare that to would more students walk or ride the bike. So you're going to add to your biking, get your new number, and then see if it's more or less than walk. Okay, as always, feel free to do this on your Google Doc or have your parents take a picture and email it to me.